we're going to take a look at Chapter 1 of our Social Science Research Principles and Terminology text. And in this chapter, we're going to look at sampling techniques, types of variables, research designs, and types of graphs. This is very much an introduction to the basics of statistics and how we're going to be able to take statistics and interpret them into meaningful ways. So the first term we need to be aware of is a population. The definition of the word population would be a collection of cases, groups of people, or people that have a specific characteristic. So a population could be adult males in the U.S. because they all share the characteristic of being male and living in the U.S. So populations can be very large because of things like that, or they can be very small. So a population could be the third grade class at an elementary school. So it doesn't have to be a massively large group, but it really depends. They have to all share a certain characteristic, and it has to be the overarching group that you're looking at. Any statistic that's calculated from a population is going to be called a parameter. So we're going to have specific words for populations and samples. Parameter is the correct term for a population. When we have a sample, it's where we take a collection of people from the grouping of the population and it creates kind of a subgroup. That's what this picture is illustrating to you, is I'm picking some people out of that population, and that's going to be my sample. When I'm dealing with that situation, that's a statistic and not a parameter. So if my population is adult males in the U.S., perhaps my sample is a random selection of 300 males in the U.S. So it's going to be a subgroup, and a lot of times it's a much more manageable group. So whereas to ask every male in the U.S. is a pretty difficult task, if I try and narrow that down to 300, that's a much more doable task. So what are the two types of statistics we're going to look at? Inferential and descriptive. They're each going to have their own purpose and their own use. Inferential statistics come from sample data, and they're used to make decisions or inferences about the population where the sample came from. So I'm not making the decision about my sample, I'm making it about the population. And so I'm inferring something. In this type of statistic, I want to be able to make a generalization. So I want to be able to have a finding in my sample that's really consistent and reliable and say, okay, because I have seen this in my sample, I can generalize it and say it to my population. So if we stick with those adult males, let's say that adult males are more likely to have long-term cardiovascular issues with COVID. So if I find that in my sample that's true, then I could infer it's true about the population as a whole. In descriptive statistics, the goal is completely different. So inferential, I'm trying to make a decision, I'm trying to make a generalization, but in descriptive statistics, I'm just trying to describe things. I'm not going to make a decision, I'm not going to make a generalization, I'm going to say that, hey, I found that on average, 67% of males in the sample had cardiovascular issues with COVID. I don't go any further than that. It's just a description. So most of the time, it's where I'm describing a mean or an average for a sample, and I'm just explaining what I saw as I worked with that sample. Generalizing that to the population then is not the objective, because I just want to describe what I saw. So there's several different ways to sample things, and I have a handout that I'm going to attach to this announcement on sampling methods. So you'll also have that handout for your help. There are three main sampling methods that we are going to study in this course. That is random sampling, representative sampling, and convenient sampling. Random sampling does not mean randomly selecting people. That is a huge misnomer in statistics. What that means is I have a systematic way of selecting random people from the population. So notice how I said systematic way. So a systematic way as opposed to a selecting systematically means that I would use a random number generator. And so The idea being, if I pick 100 numbers myself, they're not truly going to be random. So I'm going to use that random number generator because it gives every number an equal chance of being selected. Once I have those random numbers, I'm going to go to my population and pull those people out, and that's going to be my sample. So it's not as simple as being at Starbucks and just picking random people that come in the door. There is a method to the madness of random sampling. Representative sampling is a method in which we're purposefully selecting people to create a sample that's going to represent my population on certain characteristics. So, for instance, on this one, if I want to equalize representation of genders, I would somewhat be skewing my random sampling because I would have to make sure that I have a certain percentage of males and females. So this is more of a representative sampling because I have to maintain some kind of makeup of the population. Representative sampling can be pretty expensive because it's difficult to do. And it also increases the time because the time that you're taking to find the sample is really increased. So the gold standard is really random sampling, not necessarily representative, although representative might seem like it's a better option. Convenient sampling is exactly what it means. It's people who are convenient to you as the researcher. So it's selecting people because they're easy to get to. If I ask my whole neighborhood, that is convenient to me. So that's going to be a convenient sample. Now, when I talk about variables in a study, we're going to have variables that are going to be anything with more than one value. So something that's variable is something that varies or something that changes, like income, gender, age, height, score of a measure of depression. Those things can vary from person to person, and they have more than one possibility. So those are going to be considered variables. So I have types of variables. My quantitative variables are going to be number-based variables. So if something is quantitative, it's going to be based on specifically quantifying something, an amount. If it's qualitative, then that's going to be based on categories or some other non-quantifiable thing like small, medium, large. That's technically qualitative. I could assign them number values to force them into the quantitative box. Things like eye color. Eye color would be qualitative. I can't really quantify the color blue. So we have categories and then we have quantitative variables, which are typically continuous, meaning I can be like 38.7 years. So I can have a decimal variation there. Temperature can have a decimal variation. So that's what we mean there by continuous. If I am measuring variables, there's a couple different ways I can do it. I can do them based on a nominal scale, which is basically based on a category. So something that's going to be in a category is something that has a label that's not necessarily meaningful. So male and female could be a nominal variable. It's a category. And if I say, oh, tell me 1 if you're female or 0 if you're male, that number doesn't really have any meaning other than the fact that it's a label. An ordinal variable implies that order matters. That's something like small, medium, large. Small is smaller than medium. Medium is smaller than large. So the order does have some meaning there. Interval or ratio level variables are going to be numbers with equal distance between each number. So time. Time can be interval ratio. And if I wanted to do something ordinally with time, if you're looking at that picture, you're like, why does that say ordinal? That would be like first, second, third, fourth, fifth place. So if I'm just looking at placement, that's ordinal. If I start looking at the time that their placement occurred, that's going to be interval or ratio. And with interval or ratio, we like to keep those increments equal so that when we create graphs, they are equal. So if it's not equal, so like they didn't come in equally in each place, a lot of times we're going to force that to happen. Dependent and independent variables you've probably seen somewhat in other courses that are related to math. The dependent variable depends on someone else. The independent variable doesn't depend on anyone. So the independent variable is basically what am I changing or introducing to the group, and the dependent variable is what am I expecting to change based on what I introduced. So an example of this would be energy level can depend on how much you eat. In this case, energy level would be the dependent variable and how much you eat would be the independent variable. So let's take a look at research designs. What are the different ways that we can design research that makes sense? The gold standard is always experimental research design. This is always what we want to do. The hallmark of this type of research is that we're manipulating certain aspects of the research and we are controlling for other aspects. This usually means that we're going to manipulate that independent variable. So maybe we're going to do it randomly. Maybe we separate people into groups and we manipulate a protein bar that they're given. Some groups are given 2 protein bars, some groups are given 1 protein bar, and we're trying to find out what does the energy level respond to. In this type of design, a randomized control trial is really the most common research approach because it has the most substance in the community, and that involves random assignment of participants and providing the treatment. So that's taking and randomly sampling people and then providing the treatment or intervention with one group while the other one gets a placebo. So that is really our gold standard. We kind of question anything that's not done in that way a little skeptically, and that's okay. It benefits because it allows the researcher to really isolate one thing and study it. And it is a more reliable look at what's happening with the independent and dependent variable. The drawback is it's incredibly expensive and it's difficult to accomplish. Think of how hard it was to get a new cancer drug approved. This is really difficult. And part of it goes into there has to be a very rigorous experimental research design. There has to be a randomized control trial, and there has to be repeated data that exemplifies that something is working. So while it is a gold standard, it is not easy to achieve. It's not easy to get people to sign up for, and it's not easy to maintain. So more often than not, we take a quasi-experimental research design. Now, what does this mean? It's very similar to experimental research, where we're manipulating something within a group of people. However, this is going to happen in a naturally occurring place or group rather than a really controlled laboratory setting. What this does is it allows the researcher to test the effect of an experimental manipulation in a more real-world way. And the drawback is the conditions are difficult to control because it's not fully experimental. So if I'm looking at, a cancer drug, I may just look at people that are at one treatment facility. And that is people that are happening in the natural thing. I might look at one type of cancer. So I'm not getting a whole group together, separating them out along geography and everything else. And I'm not controlling for every aspect in the study like I would be in the other type. A correlational research design is probably a lot less common in the scientific fields, but it's still acceptable. A correlation research design does not imply causation, it implies a relationship. In this case, variables are not manipulated by the researcher. We're just looking to find out, hey, is it possible that there's a relationship between these two things? So the benefits of this are it's way easier to design because half the time it's something that already exists. It allows for the inclusion of a lot of different variables, and it allows us to look at the relationship between many variables in one study. So in this example, if I want to look at the final exam for this course, and I want to say what is the relationship between the hours spent studying and the score in the exam, then I could sample you guys and say, hey, how many hours did you spend studying for the exam? And then I could look at your scores and I could determine if there's a relationship. And we're going to learn later on how to know if there's a relationship from that graph. So just kind of take that with a grain of salt for now. The drawback is it doesn't allow for any control, so it's not widely accepted. And it doesn't give us any causational information. So 9 times out of 10, somebody is misled because they say, oh, this causes this. And that's not. There is some relationship. We don't know what it is. We don't know how much it is. We just know they're related. So it can seem a little bit redundant when you look at it that way. And the last thing is we're going to look at some graphs of data. So graphs can be done correctly or incorrectly, surprisingly. A pie chart is going to be used when I have categories. So pie charts are used with categories. Specifically, they're used when I want to compare categories of one to another. So if I want to compare how many people are Republican, Democrat, or Independent, a pie chart is a good choice because the percentages give me a really nice comparison. And the way the colors are used is a great comparison. So this is really great for qualitative data that's going to be very categorical in nature or nominal. A bar graph, on the other hand, has to have a number involved. So I can take that same data set that I had with the pie chart, and I can technically make a bar graph by just making the percentage that numerical vertical side. So technically this is still qualitative data. This is still categories, but what I'm doing is I'm kind of showing the frequency that people say they're Republican versus Democrat versus independent. And it does give it's a comparison view. So in this case, if the percentages aren't extremely important and you're just trying to show the distribution of people, a bar graph can be a really good choice. A line graph is used with time. So line graphs really only make sense when they're over a duration of time and you're trying to graph something that's quantitative. So in this example, I'm documenting the hours that these animals sleep over multiple days to make an inference of what's going on. So a line graph makes sense because I'm graphing hours, which is quantitative, and I'm doing it over a period of time, which is going to be that x-axis. And that's typically always going to be the pattern with a line graph. You're going to see that x-axis as being over the distance in time. So in summary, statistics are calculated and interpreted as a part of a larger research design process. We don't just get to those numbers very easily. Every aspect of that process is subject to scrutiny, from how you select your samples, what the variables are, how you controlled for them, how did you find the data, and then last, what is the representation you're using for graphs. All of that is subject to scrutiny. And it's really important to understand the entire process as a whole, because then if we don't understand that, we can't give statistics meaning and we can't question if they're really valid or reliable. So if I have a sample size of 3 people, but I come on TV with my commercial with 100% effective drug, and somebody doesn't think to say, wow, that's really weird, I wonder how many people they surveyed. Or ask your doctor, okay, that's the percentage you gave me, how many people have you seen? Those are the questions that, leaving this class, it's my hope that you ask, because you've been through the research design process. You've been taught to really think critically about the numbers that are given to you so you can make really valid and accurate decisions for yourself.